Bismillah ar-Rahman ar-Rahim. We are discussing second year mathematics. In this video, we will discuss how to take integral by the method of substitution. We will discuss all the situations one by one. When you have this type of situation, what you will do. When you have this type of situation, when you have this type of situation, what you will do. So first of all, we will discuss our first situation. It is most easy. So what should you do when you have a square minus x square? Hey, a is constant and x is variable. Simply take minus 1 as a common, so this will become x square minus a square. So only consider only positive. At the end we will put negative sign, so making factors of x square minus a square, so this will become x minus a, x plus a. Making partial fraction of this one, so partial fraction of this is equal to this one, so this is equal to this one. Simply you will let for this and this, you will let x plus a is equal to u, taking derivative of this one. We have discussed this in the previous video, how to take the derivative of this type of situation. So this will become 1 over u is equal to natural log of u. The derivative the integral of this one is equal to this one, and the integral of this one is this one. You can also find the integral by simple situation. When you have this type of situation, when you have situation like this one, when you have f of x here and f prime of x here, then it is equal to natural log of f of x. Okay, so when you have f of x in denominator and derivative of f of x in the numerator, the integral of this one is equal to natural log of f of x. Similarly here, that x plus a, taking derivative of this one, the derivative of this one is equal to 1, and x minus a, the derivative of this one is equal to 1. So here this is f of x and this is f prime of x. You can write it as the integral of this one is equal to natural log of x plus a. Similarly here, when you take the derivative of this one, the derivative of this one is 1, so you can write it as natural log of x minus a. Okay, so now putting all the values, taking 2a as a common. When you take 2a as a common, so this will become by solving this one is equal to this one. So you know that log of m minus log of n is equal to log of m divided by n. So the integral of this one is equal to this one. Okay, now when you have a situation like this one, when you have a situation of a square minus x square under the root, so in this situation you will let x is equal to a sine of u, x is equal to sine of u for theta is greater than minus 90 and less than 90. So taking derivative of this one, this is equal to this one, dx is equal to this one. At the place of x, we will put a sine of u, and at the place of dx, we will put a cos of u. Simply putting the values, we will get this one, taking a square as a common. So a square, 1a is with this one and 1a is this one, so they will become a square. So at the place of 1 minus sine square u, we will put cos square u. So this is cancelled with this one, cos of u into cos of u, cos square u. Now how to take the integral of cos square u? How we will take the integral of cos square of u? Now use product to some formula in the equation. This one, we know that cos of alpha, cos of beta is equal to this one. At the place of alpha and beta, we will put u. So cos square u is equal to 1 divided by 2 cos of u plus u, cos of u minus u, 1 divided by 2 cos of 2u plus 1. So simply cos square u is equal to 1 divided by 2 cos of 2u plus 1. So this is equal to this one. So putting the values, when we will put the values, we will get this. Here we will put the values, this one. So taking the integral of this one, So the integral of cos of 2u is equal to sine of 2u divided by 2, and the integral of 1 is equal to u. So simply putting the values, this one, and now again this is equal to this one. At the place of sine of 2u, we will put 2 sine of u cos of u, and this is equal to this one. So at the place of cos of u, we will put 1 minus sine square u, and this one, and simply now substitute the return in equation number 3. We let x is equal to a sine of u, and sine of u is equal to x divided by a, and u is equal to sine inverse of x divided by a. Putting all the values, so this will become the integral of this one is equal to this one. Okay, now when you have the situation of this one, 1 divided by a square minus x square, so here you will also let x is equal to a sine of u. So putting the values, at the place of dx we will put this one, at the place of x we will put this one. So putting the values, at the place of x square we will put this one, and at the place of dx we will put this one, and after simplifying this one we will get this one, and the integral of 1 is equal to 1 du is equal to u plus c. Simply put the value of u, which is equal to sine inverse of x divided by a. So this is equal to this one simply. Now when you have the situations like this one, what should you do? When you have a situation of a square plus x square under root a square plus x square under root x square plus a square. Now what should you do? Integral of a square plus x square, simply let u is equal to x divided by a. So du divided by dx is equal to 1 divided by a. So du is equal to 1 divided by a into dx. Simply putting the values at the place of so this is equal to a du is equal to dx. So dx is equal to this one, and u is equal to this one, and x is equal to u into a. So putting the values, all the values, u is equal to x divided by a, du divided by dx is equal to this one, dx is equal to this one. So simply putting the values, a at the place of x square we will put u a, and this will become a square u plus a square. So this will become 1 divided by a square as a common. So a square as a common, 1 a is cancelled with this denominator a. So when we have left only a, so 1 divided by u square plus a. The integral of this one is equal to tan inverse of u. We know that when you take the derivative of this one, tan inverse of u, this is equal to 1 divided by 1 plus u square. So simply when you take the integral of this one, you will get this one. Okay, so put the values of this one in the equation. So this is equal to this one. Okay, now when you have the situation like this, the answer of this one, when you have the situation of under root a square plus x square dx, so this, by using the trigonometric substitution, in this type of situation you will let a is equal to tan of u, taking derivative of this one, so dx is equal to this one, and now simply putting the values, so when you put the values we will get this one. When you simplify this, we will get this one, we will get this one, and at the end you will left with this one. Now how he take the integral of secant cube of u. So secant cube of u du, you can write it as secant square u dot secant u du. Okay, so this is equal to 1 plus tan square u into secant of u du. Okay, so this is equal to secant of u plus tan square u secant of u du. Now take integral of both of these two, secant of u du plus integral of tan square u secant u dot du. When you take the integral of this one, you will get this one. natural log of this one. And when you do the integral of this one by integration by parts, integration of by parts we will discuss in the next topic. So when you take the integral of this one, you will get this one. So we do the integration of this by integration by parts. Integration by parts we will discuss in the next video. So putting all the values, you will get this result. Okay. So when you have this type of situation, so the integral of this one is equal to, when you take the integral of this one, this is equal to this one. Okay. Now when you have the situation of like this one, x square plus a square, what should you do? You will let x is equal to a tan of u. So this will become this one. At the place of dx we will write this one. At the place of x square we will write this one. So putting all the values, simplifying this one, at the end we will get only secant of u. The derivative, the integral of secant of u is equal to this one. So this is the our final result. Okay. Now when you have the situation like these, x square minus a square and x square minus under root x square minus a square and under root x square minus a square, what should you do? So simply by using the trigonometric substitution, x is equal to a secant of u. So this will become this one. So putting the values, so this is, after simplifying this one, you will left only this one. So the integral of this one is equal to this one. Now again putting the values, so the u is equal to this one. So all the values, you will get the final answer. When you have the situation like this one, what should you do? Like this situation, x square minus a square. So simply x is equal to this one and dx is equal to this one. Putting the values, when you put the values and simplify this one, you will simply left with the integral of this one. So after simplifying this one, we have discussed how to take the integral of this one, and this is also easy. The integral of this one is equal to natural log of this one. So after simplifying this one, you will get the answer. You will get the answer which is equal to this one. Simply when you have the situation like this one, under root x square minus a square, what should you do? Simply substitute a is equal to secant of u, taking derivative of this one, dx is equal to this one, putting the values. When you put the values, after simplifying, we will get only this one, and the integral of this one is equal to this one. Now after this, substitute the original values and get the answer. Now when we will have the situation like these, ax square plus bx plus c, the integral of this one, to proceed this kind of integral is stated in the following example. When you have this type of situation, what should you do? We make the this one, this is equal to this one. So let q is equal to this one and this is equal to this one, and putting the values, and the integral of this one is equal to, we know that the integral of this one is tan inverse of u plus c. Now use the trigonometric substitution in the equation 1. You will get all these things. So you will get this one, and return substitution. Putting the values of u, you will get the answer. Simply similarly, when you have this kind of situation, when this is in the under root, what you will do? When you have this type of situation, you will let u is equal to x plus 2 and this is equal to this one, putting the values this one, and now use the trigonometric substitution in the equation this one. So this is equal to this one. Okay, so simplifying this one, you will get the answer. Now when you have the situation like this one, when you have the situation like this one, what should you do? This is the example. Okay, so this is equal to this one. So now use the trigonometric substitution in the equation 2, u is equal to this one. Okay, So putting all the values, you will get this one. Okay, putting the values of u, you will get the answer. When we have this type of situation, what should we do? So again, all the things, let this one, and this one use trigonometric. Okay, putting the values, so we'll get that integral of this one. Now we will discuss the exercise 6.2. So first question we have this one, second question is this one, third question is this one, and fourth question is this one. So in the next video we will discuss all these questions.